drawing of foundation and retaining wall. Last class we have stopped here. So in last session we have gone through how we can calculate the area of the foundation and how we are going to fix the positions on the combined footing, and we have gone through how we are going to calculate the shear force and bending moment for the in longitudinal directions. Now in this session we are going to see about how we are going to calculate the depth of the foundation, depth of the footing. So in IS 456 page 70, provided that what is XU by D ratio for different reinforcements. So if you are using reinforcement of having FE 250 bars, you are going to use this value. If you are using FE 415 bars for reinforcement, you are going to use this value. In the same case, in the same way, if you are using FE 500 bars, you are going to use XU by D value. So for the corresponding moment, limiting moment will be this one. So using this formula, if you are using FE 250 bars, so you are going to use moment, limiting moment equal to 0.149 FCK BD square. So here this is the depth of the foundation. Here it is the width of the foundation. Here moment will be the maximum moment, whether it is a hogging moment or sagging moment. We are going to use the maximum moment which we have calculated already in our fourth step, that is bending moment. So if it is hogging moment or sagging moment, you are no need to worry about that one. You are going to take the maximum moment out of the three moments. So you know the maximum bending moment and you know the FCK value, what is the grade of the concrete you are going to use, you know the width of the foundation, so you can calculate the depth of the foundation. After calculating the depth of the foundation, the next step is to check for the punching shear, because the punching shear, the critical dimension of the foundation is the depth only, because the punching shear itself known as the punching of the column into the footing. So if you are not providing a sufficient depth, definitely the foundation will fail in punching shear. So the critical section for the punching shear is at the distance of d by 2 from the face of the column. We already discussed this one. So we are going to consider this area for the for checking of punching shear. So we used to do the punching shear check at heavy column. Heavy column means if one column is carrying 60 kilonewtons, one column is carrying 90 kilometers, then 90 kilonewton carrying column, we call it as a heavy column. So if the check is safe for heavy column, then obviously it will be safe for the light column also, na? So we used to do punching shear check for heavy column only. So the punching force will be the downward W2, that is load from the column, and upward pressure from the soil. So P0 is the net upward pressure. We have to convert that into the kilonewtons, so that we need to multiply with the area. So this is the area which is crucial for the punching shear. So we are going to use that area A0 into B0. Then we need to factor that punching shear by multiplying with the 1.5. So using the factored punching force, we are going to calculate the tau V value. So tau V would be V0 by perimeter into the depth of the foundation. So after calculating the tau V value, we need to calculate the punching shear stress, that is tau V dash. So Ks into tau C. Tau C will be taken as 0.5 into root FCK as for IS 456, and Ks value is the modification factor, which again we are going to take from the IS 456 table 72 clause 40.2.1.1. There they are going to there is one table which is having the relationship between Ks and the depth of the foundation also. From that table we are going to take the Ks value and we need to calculate the permissible shear stress. If the nominal shear stress is less than permissible shear stress, then the foundation, whatever the depth we are provided for the foundation is safe in the punching shear. If it is the nominal shear stress is more than permissible shear stress, then we need to redesign for the depth by using the following formula. So this formula we are going to use to calculate the revised depth for the foundation. So that depth we are going to use for the in the next part of the calculations. So this is the minimum depth. So this is the minimum depth we are going to provide for the foundation. So this depth, so we need to revise the depth of the foundation. Then reinforcement calculations. For reinforcement calculations, we are going to use this formula. This is formula we got from the moment of resistance equations to by solving for the AST. Here you know everything. FCK you know, B is the width of the column and D is the depth of the column we have provided. Here M is the critical part here. If we are designing the reinforcement, the sagging moment, we are going to use the sagging moment of the sagging moment where we got in shear force and bending moment diagram. We are going to design for the design reinforcement for the hogging moment. We are going to use that hogging moment, whatever the moment we got at the middle span of the column, that is subject to the hogging moment. In that way, we are going to calculate the different reinforcement for the different portions of the foundation. So after calculating the AST, we need to decide what is the diameter of the rebar, so that for the sagging moment, I already told you, we have to play in the detailing, we have to place those reinforcement at the top fiber and at the bottom fiber. For a hogging reinforcement, we are going to place that reinforcement at top fiber of the foundation. After calculating the reinforcement, we have to do particular checks, that is one way shear checks and one way shear check, and then we need to calculate the transverse reinforcement. That we are going to see in the next session. Thank you.